How to fix unreliable robot sensor tests. Imagine building a robot that needs to see, feel, or sense its environment perfectly. Now picture that sensor giving inconsistent readings. That can cause big problems. Unreliable sensor tests often happen because of interference, poor calibration, or environmental factors. To fix this, start by checking the sensor's accuracy. Compare its output with known reference values to see if it detects small changes correctly. If it doesn't, recalibrate the sensor to match standard measurements. Next, test how the sensor performs in different environments. Electromagnetic interference from other electronics can mess with sensor signals. To check for this, expose sensors to controlled electromagnetic fields and external sources. If interference shows up, improve shielding by adding metal enclosures or grounding the sensor properly. Choose sensors with better resistance to electromagnetic interference if needed. It is also important to test how quickly the sensor responds to changes. Dynamic response testing involves moving the sensor or changing conditions rapidly and observing if it keeps up. This is especially important for robots working in fast-moving or unpredictable settings. If the sensor lags or delays, it can produce unreliable data. Adjust the sensor settings or choose faster sensors to improve response times. Long-term stability is another key factor. Run sensors continuously over hours or days to see if their readings drift or degrade. This helps identify issues like sensor wear or component aging, which can cause unreliable results over time. Regularly monitoring sensor health can prevent unexpected failures. Using multiple sensors measuring the same thing can also boost reliability. Cross-verify their output so if one sensor gives inconsistent data, the system can rely on others. This redundancy makes the robot sensing system more dependable. Always document your test results thoroughly. Record sensor outputs, environmental conditions, and any anomalies. This helps troubleshoot issues and refine calibration procedures. Incorporate predictive maintenance by analyzing sensor data over time. Using data analytics or simple AI tools, you can spot early signs of sensor failure. Fixing issues early keeps your robot running smoothly. Finally, make sure your sensors meet industry standards and certifications. Certified sensors have been tested thoroughly and are more likely to give reliable readings. When building or prototyping robots, always test sensors under real-world conditions that match your robot's intended environment. Use simulations and physical tests to validate sensor performance before deploying. Following these steps will help you improve sensor reliability. Reliable sensors lead to more dependable robot systems, whether you are learning, building, or developing advanced prototypes.